Thank you for joining this presentation on enhancing electrical safety for higher voltage DC systems. I am the Director of Product Marketing at Grace Technologies and will be sharing some of the higher voltage DC application areas that have driven Grace to develop new electrical safety solutions to meet customer requirements. Please enter your questions into the chat and I will respond to them either at the end of the webinar or follow up directly if time does not permit or I need to consult with other team members to provide a better answer. Grace Technologies is a family-owned business with a factory at our Davenport, Iowa headquarters. We have helped make maintenance safer, smarter, and more productive by providing millions of panel interface connectors and permanent electrical safety devices, or PESDs, to minimize electrical injury risk by reducing the need to open a panel door to access data or power or verify the absence of voltage. Our Grace Sense continuous thermal monitoring and asset condition monitoring solutions help prevent hazardous electrical unplanned maintenance and increase asset availability and worker safety. The perpetual energy harvesting solutions were added so we could offer batteryless condition monitoring and process instrumentation. We have had requests for through-door test points for absence of voltage testing for DC voltages over 1,000 volts. Initial requests were for 1,250 volts DC, but requirements have continued to grow to 1,500 volts DC for utility solar scale plant applications to over 2,000 volt DC for electric vehicles. While the percentages and numbers you see on the screen may vary depending on the source, OSHA remains the best source for reported incidents. Testing for the absence of voltage inside of a panel is unfortunately a leading cause of arc flash and electrical injury. The retirement of many qualified electricians and high turnover at maintenance services companies, there are more early career and less qualified workers performing lockout tagout. Adherence to electrical safety programs may not be as high as needed to keep workers safe. It is likely that many of you are experts in solar power generation or electric vehicles, but in case some of you are not as familiar with one or more of the applications, I will start with a brief overview of each. This discussion will focus on utility scale power generation, though the principles apply to residential or commercial distributed generation, the generated power and voltages tend to be lower. The image is of a solar power generation plant with on-site battery storage. It does not show the solar array detail, which includes combiner boxes that aggregate energy from individual solar panels and can result in up to 1,500 volts DC on the load side that feeds into the DC to AC inverters. Maintenance of combiner boxes and inverters is a main source of electrical hazard. Without a through panel means to perform absence of voltage testing, electrical safety program procedures, including wearing proper personal protective equipment, must be followed. The combiner box, typically located near the photovoltaic array, is a device that combines the output of several PV strings into a single DC output. It can operate at voltages up to 1,500 volts DC and contains the fuses, circuit breakers, disconnect switches, surge protectors, and monitoring devices. The combiner box is exposed to harsh environmental conditions, increasing the potential for faults or failures. In particular, the local break disconnect switch may not fully open and isolate the solar array strings due to mechanical failure or wear or loose or damaged connections. The ability to quickly verify the absence of voltage before opening the panel for service significantly reduces the risk of electrical injury. Utility scale power and solar power inverters are fed by many combiner boxes at up to 1500 volts DC on the input side and invert the power to up to 600 volts AC on the output, which is then stepped up to transmission voltages, for example, 34.5 kV in this image. Exposure to high power on both the input and output sides during the absence of voltage testing for lockout tagout for maintenance can be mitigated through panel test points for the absence of voltage testing. Note that push button style AVTs are not rated for over 1000 volts and may not be used on the DC input size if the voltage is over 1000 volts. In the next couple of slides, I will share some of the use cases for which Grace has had requests for greater than 1000 volts DC safe test points to support through panel absence of voltage testing. Manufacturers of off-highway vehicles like mining trucks are adding battery power to hydrogen and hybrid options to support mining decarbonation or zero emission efforts. Given the size and load of these vehicles carry, that is an amazing amount of battery power, 1.4 megawatt hours in the example on the slide. Using solar power to charge batteries helps to achieve the zero emissions goal. While the electric rail has been used for many years, either AC or DC overhead lines or the DC powered third rail typically used in subway systems, some newer rail systems are now being powered by batteries. Examples include mining trains that can charge their batteries on a downhill run to port and 100% electric heavy haul locomotives. Both systems may use greater than 1000 volt DCs. Public electric vehicle charging stations seem to be everywhere now. While we typically focus on the charging stations in the image to the left, the substations powering them tend to be less visible. The image to the right is a 1320 kVA multi-secondary mini substation with utility low voltage gear. Both the charging station and substation will require service, with the amount of power increasing as new fast charging standards are deployed to support newer EV battery technology. Due to the large number of stations in a wide geographic area, maintenance of public EV charging systems is very likely to be outsourced. This slide is not meant to be sensational, but to drive the point that technicians servicing EV charging stations may be exposed to electrical hazards that can cause serious injury or death. In addition to EV charging safety components such as arc fault detection and interruption required by NEC 690.11, through panel testing for the absence of voltage helps reduce the risk of maintenance workers who may not be as experienced as qualified utility and industrial electricians. Moving over to look at the standards, as solar power generation and battery electric industrial vehicles evolve, I encourage you to work with organizations to help UL, NEC, NFPA, and other standards keep up with the industry changes. Most utility, mining, and rail operation companies have an electrical safety program aligned with NFPA 70E, and many have an electrical maintenance program following NFPA 70B, which has transitioned from a recommended practice to a standard in the 2023 edition. 70E describes how to achieve an electrically safe work condition, and 70B describes the condition of maintenance of electrical equipment and systems for safety and reliability. Extension of and ensuring compliance with electrical safety programs and electrical maintenance programs by maintenance subcontractors is critical to helping reduce the electrical hazard risk of workers who may be less experienced due to being earlier in their career or due to higher turnover. In case of audit or inspection, OSHA is going to ask you to demonstrate how an electrically safe work condition is achieved. NFPA 70E standards provide guidelines on how to achieve an electrically safe work condition. Always understand that residual risk exists. What is residual or acceptable varies by organization, management, and individual workers. Minimum personal protective equipment requirements depend on your company's safety policy and tolerance for risk, but are defined in NFPA 70E. Until the electrically safe work condition is established, employees must be protected from hazards. Risk reduction is key to creating an electrically safe work condition. Use the risk control hierarchy principles of elimination, substitution, engineering controls and awareness, administrative controls, and personal protective equipment are used to reduce risk to an acceptable level. Grace Technology safe test points and CheckVolt eliminate the need to open a panel to perform absence of voltage testing, an example of elimination. Our voltage indicators are used to increase awareness of the presence of voltage, for example, from residual capacitance. Our current line of high impedance safe test points support through panel testing for the absence of voltage up to 1000 volt AC or volts DC. They are approved with transients up to 8000 volts, which makes them suitable for Cat 3 1000 volt AC and Cat 4 6000 volt AC uses. In 2023, we started offering a permanent electrical safety device that combines voltage indication and safe test points in a single 30mm knockout. It was initially released to support up to 1000 volts AC and 1000 volts DC. As we have received requests to support DC voltages up to 2500 volts DC and have looked at designing a product to meet the request, we understand that most multimeters are limited to 1000 volts or less. The Unity UT892 is an exception with a 60 megohm internal resistance that allows up to 2000 volts use. Other options include using higher voltage test probes, for example, the Fluke 15 kV and 40 kV probes with an internal 1000 to 1 voltage divider, or designing your own voltage divider. We integrated a voltage divider in our new higher voltage DC safe test points so users can use standard voltmeters. We are launching our new 3000 volt DC safe test points and check volts to support the many requests for higher voltage DC through panel absence of voltage testing. There are 3 versions. There's a 2 and 3 wire 3000 volt DC check volt that have safe test points and voltage indication, and a 3000 volt DC line load safe test point for combiner box and other applications. These products are rated for tough environments up to 75C and IP69K. That concludes the presentation portion of this webinar. And now we'll take some questions.
Hey everybody, if you have any questions, feel free to drop them in the chat right now. I do see a question about the copy of the presentation. We will be sending out the PowerPoint presentation to everybody who attended, along with an on-demand link to this video. Thank you for attending. Wait a little while for questions to come in. Will the DC version have the indicator lights as well, Kevin?
Yes, the DC version of the 2-wire and 3-wire will have the voltage indicator lights. The line load version for use with combiner boxes, the 4-wire, will not have the indicator lights.
Kevin, while we're waiting for some more, I'm writing a blog. I kind of want a capstone on your presentation today, and I read that in 2021 the United States added a record 19.2 gigawatts of solar capacity. In other words, the solar is expanding rapidly. So, you want to touch on the importance of keeping up with that demand for electrical safety and for us to kind of match expansion of that industry?
Sure. So in addition to the expansion, and actually I've seen where solar expansion is outpacing wind. I'm not an expert in why that is, but we're also seeing use of new technologies such as bifacial panels that are increasing the power that's being generated. So as we see that expansion, there'll be likely potentially more operation companies as opposed to utilities doing that. There might be more use of contracted maintenance electrical workers servicing those solar fields. So the importance of keeping those potentially third-party workers and a growing workforce at the operating and utility companies safe. It's important to keep your electrical safety program up to date as we see more and more solar.
Right. A couple other comments in here. A couple of people thanking for the presentation. The information was great. And then can we share this presentation with customers? Absolutely. Share this with anyone you think would find this information valuable. Another question here. Can you provide an estimate of when the 1,000 plus volt products will come to market? What IP ratings and vibration resistance will they have?
So we're anticipating by the end of next month, early August, we'll have production level quantities of the 3,000 volt versions of the products. We have samples. We can have samples available sooner. We've completed our UL testing of the devices. They are rated to IP69K, similar to our 1,000 volt versions of the products. And as far as vibration, I don't know the vibration spec. I'll have to get that to you.
Are these applicable for residential connections, or is there going to be a different version?
So the residential connections will most likely have a lower power than what we've been driven to for the utility scale operations, but our standard products could be used in a residential connection or perhaps a larger distributed generation application, for example, in a commercial building, where you have a solar array and multiple combiner boxes. You could use that to help stay safe while servicing that equipment.
All right. And then just while we're still going through some questions here, I'm launching our poll. If you guys want to learn more about the check volt, you can feel free to request a sample by clicking that box right there. We also have an expert network electrical safety program consulting. If you want more information on that, click that as well. But I'm going to keep going through these. In the meantime, what is the voltage limit for test points on an indicator light with test points?
Up to 3,000 volts DC.
I love this comment. So thank you all for the information, and we used your components in just about all of our custom panels. Thank you for the invite.
Thank you very much.
Thank you for the invitation. You bet. I'll just leave this poll up for a little while. I'm curious too, Kevin, while we wait for people to fill this out. When I first heard about electrical safety, I was a little confused. I see the electrical charging stations everywhere, and I know they're popping up all over the place. And I was like, what part of that requires safety?
So you're typically you can be powering those stations either. Sometimes you'll see solar panels that are providing the power. There could be battery storage. If you're not getting production from the solar panels, or most often a connection to the utility system. So you can have essentially a substation nearby those solar panels. So there's higher voltage coming into that substation, and then increasingly higher voltage DC being used for the faster charging. So there's as more of these stations proliferate, which is great for drivers of EVs, there's going to be an increasing need to service these substations, these charging stations, and their equipment.
Seeing anything else coming in? There's about 84 people still here. You guys speak now or forever hold your peace. Yeah, if you haven't yet, go ahead and fill out that form. And like I said, we will send you the presentation slides as well as the video. It'll be on demand. We'll post it to our YouTube channel. And we'll also include a link in the email in case you missed the poll. A lot of people probably weren't able to make it today, so we'll make sure they get it as well. I think that's about it, Kevin.
Okay, well, thank you all very much for joining. I appreciate your time today.